Advanced space-based observations have revealed something no one expected: unusual structured light patterns detected from an interstellar object known as 3I Atlas.
The discovery hit the astronomical community like a shockwave. When NASA publicly released the newest set of James Webb Space Telescope data concerning the interstellar object known as 3I Atlas, what had once seemed like a fascinating curiosity suddenly became something far more profound and far more unsettling. For years, scientists had debated whether interstellar visitors such as Oumuamua and Borisov were merely odd remnants of distant solar systems or something that hinted at a deeper, stranger cosmic story. But the James Webb Telescope, with its unmatched sensitivity and ability to probe distant worlds in unprecedented detail, has now given humanity its clearest look yet at such an object. What Webb saw in 3I Atlas was nothing short of astonishing, and in some ways, deeply troubling. Before we start, smash the like and subscribe buttons for more updates. When 3I Atlas was first detected in 2024, astronomers recognized it immediately as only the third confirmed interstellar object ever observed passing through our solar system. Its trajectory was unmistakably hyperbolic, meaning it could not possibly be gravitationally bound to the sun. It had come from the stars, a wanderer flung across the cold depths of interstellar space. Early telescopic observations showed an object that seemed faint and irregular, but its surface composition was difficult to determine. Ground-based telescopes hinted at unusual reflectivity patterns, something that didn't quite match the dusty, icy profiles of known comets or the rocky, metallic fingerprints of asteroids. For 2 years, astronomers eagerly awaited the chance for the James Webb Space Telescope to point its golden mirrors toward 3I Atlas and collect real spectra. That moment finally arrived, and the results immediately forced researchers to question fundamental assumptions about how such objects form. What Webb revealed first was its spectral signature, a detailed analysis of the wavelengths of light reflected and emitted from its surface. Instead of the expected combination of carbonaceous compounds, silicates, and frozen volatiles, Webb's infrared sensors returned a complex and almost engineered pattern of absorption lines. The data suggested layered materials, metallic in nature but interspersed with organic residues of a type that had never been cataloged before. Certain bands corresponded to alloys used in spacecraft manufacturing on Earth, but at ratios impossible to produce naturally in known astrophysical processes. This peculiar composition was not immediately declared artificial, but even the most cautious researchers admitted that 3I Atlas did not behave like a normal body shaped only by geological or chemical evolution. The shape of 3I Atlas, reconstructed from Webb's high-resolution imaging, only deepened the mystery. It was elongated, extremely so, with a length-to-width ratio of nearly 10:1, and featured abrupt angular facets that did not fit the smooth curvature typically seen in natural tumbling asteroids. One of the most striking details came from how it reflected sunlight. The reflectance curve fluctuated rhythmically, almost like a rotating beacon, with precise periodic intervals that remained consistent over days of observation. Such regularity could theoretically arise from natural tumbling, but the light modulation was too stable, too deliberate. Some scientists compared it to the way engineered satellites flash as they rotate, hinting that 3I Atlas might not be an ordinary chunk of rock at all. Then came the thermal readings. Webb's mid-infrared instrument, MIRI, detected heat emissions that did not correspond to what should have been expected from a passive body merely absorbing and re-radiating sunlight. Certain regions of the object were warmer than surrounding ones, and these thermal patches shifted over time in a pattern that could not be explained by rotation alone. At first, teams proposed that volatile outgassing, similar to a comet venting jets of gas, might account for the phenomenon. But follow-up observations detected no trace of water, carbon dioxide, or other typical cometary compounds. Instead, there was an odd infrared glow at wavelengths, commonly associated with energy conversion, something more akin to radiative dissipation from an active system than a natural emission. NASA's internal analysis team, working jointly with the European Space Agency and several university partners, spent weeks rechecking the data. Calibration errors were ruled out. Instrument noise was negligible. Webb's pointing stability ensured the readings were genuine. When the findings were finally compiled, they painted a picture that defied conventional astrophysics. 3I Atlas appeared to have internal heat sources, potentially powered by mechanisms that did not fit any known model of natural radioactivity or frictional heating. The object's density, inferred from its motion and light curve, was anomalously low, similar to hollow structures rather than solid rock. Combined with its reflectivity, geometric precision, and energy signatures, the implications were staggering. As the data became public, debates erupted across the scientific world. Could this really be evidence of an artificial interstellar probe? Was it possible that 3I Atlas was some ancient relic from another civilization, perhaps long inactive, drifting through space for millennia? While NASA avoided sensational conclusions, the language in their technical brief was unusually cautious. It described non-natural spectral regularities and unexpected thermodynamic behavior, terms that hinted strongly that the agency had found something outside the realm of ordinary astrophysics. Independent astronomers quickly began to analyze the released datasets themselves, and many found corroborating signs of structured composition. The ratios of nickel to chromium, the spectral dips near 1.2 and 2.8 micrometers, every detail seemed to whisper that 3I Atlas was built, not born. The implications of this possibility struck at the very heart of humanity's understanding of its place in the cosmos. If 3I Atlas were indeed artificial, it meant that technological civilizations had existed elsewhere long before humanity's rise, capable of constructing interstellar probes that could survive the ravages of cosmic radiation and time. Even more troubling was the thought that it might not be inert, that the strange heat signatures could indicate continuing operation, however faint. Was it transmitting, observing, repairing itself? The James Webb Telescope could only see what was visible from afar. It could not answer those questions. But the mere suggestion that something built by alien hands was moving silently through our solar system sent a chill through every scientific institution on Earth. Some theorists proposed that 3I Atlas might be part of a vast network of probes sent out eons ago to map and monitor the galaxy. Others argued that the object could be debris, the broken fragment of a once functional vessel, its strange composition the result of ancient engineering. A smaller but vocal group of skeptics urged caution, noting that exotic but natural explanations might still exist. Perhaps unusual crystal lattices or metallic condensates could form under extreme interstellar conditions, creating the illusion of artificiality. Yet, even these skeptics had to admit that the combination of shape, structure, and energy behavior was uniquely baffling. As the telescope continued to track the object, a new layer of complexity emerged. 3I Atlas's motion through the solar system did not perfectly match the trajectory predicted by gravity alone. Subtle but measurable deviations were recorded, tiny accelerations inconsistent, with radiation pressure or outgassing. The data echoed the same mystery that had surrounded Oumuamua years earlier, which also exhibited unexplained non-gravitational acceleration. But this time, the precision of Webb's instruments eliminated the margin for error. The object was moving as though some internal mechanism adjusted its course, however slightly. That realization reignited the debate over whether 3I Atlas could be, in essence, a machine. Engineers studying the thermal maps noticed that the hot zones on 3I Atlas aligned with the direction of its motion, suggesting that they might serve a functional purpose, perhaps propulsion or orientation control. The emissions were faint, orders of magnitude below anything resembling an active engine, but still distinct enough to imply control rather than chaos. If this were a derelict craft, it might be operating on residual power, its systems flickering to life intermittently after unimaginable ages adrift. Some even speculated about self-repairing nanostructures or autonomous subsystems designed to sustain minimal function indefinitely. In the language of engineering, it seemed less like an asteroid and more like a drifting relic of design. Yet, the unsettling part of the data was not just its hint of intelligence, but its implications for time. Based on trajectory modeling, 3I Atlas appeared to have entered our solar system from a region of interstellar space devoid of any nearby stars within a few light years. That meant it had been traveling for millions, possibly billions, of years. If it was artificial, it was ancient beyond comprehension, the product of beings who existed when Earth's continents were still unrecognizable. The very fact that such a construct could endure the cosmic void for that long without disintegration challenged everything humanity knew about materials, science, and engineering longevity. It was as if some alien species had mastered permanence itself, embedding endurance into the molecular architecture of its creations. NASA's analysis also uncovered faint spectral hints of surface alteration, thin layers of polymerized carbon and unknown silicate compounds, possibly indicating protective coatings or accumulated cosmic wear. The surfaces seemed armored in a way natural asteroids never are, resisting micrometeorite erosion with inexplicable resilience. One intriguing clue was a repeating pattern of microscopic reflectance variation, a grid-like structure etched across one region of its surface, suggestive of deliberate fabrication. When magnified through Webb's image enhancement algorithms, it looked eerily like a tessellated panel design. It was this discovery, above all, that caused several project scientists to privately admit that the artifact hypothesis could no longer be dismissed outright. The potential ramifications extended far beyond academic curiosity. If 3I Atlas was a probe, its presence could imply that Earth had been, or was being, observed. Some researchers began to quietly re-examine radio telescope data for unexplained transmissions coinciding with the object's passage. So far, none had been confirmed, but faint transient radio bursts had been detected in similar frequency ranges. Whether related or coincidental remained uncertain. NASA publicly maintained that no signals of artificial origin had been detected, but it did not deny that monitoring continued. Meanwhile, private observatories and amateur astronomers tried to catch their own glimpses, hoping to validate the extraordinary claims. Within the mission teams, the release of the data changed everything about how people spoke, thought, and even felt about their work. Until then, interstellar objects had been exciting anomalies, demanding but familiar in the way they fit into the broader project of understanding how planets and stars take shape. Once the Webb analysis of 3I Atlas was in front of them, the mood shifted from curiosity to a quiet, almost reverent unease. Researchers who had spent their careers cataloging minor planets were suddenly grappling with the possibility that the latest entry on their lists was not a natural remnant of a distant system, but a relic of intention. Daily life inside the analysis groups became strangely bifurcated. On the surface, it was all routines and procedures, calibrating instruments, running simulations, checking error budgets, logging uncertainties. Beneath that veneer, minds raced. People who had devoted themselves to orbital mechanics now found themselves reading about information theory late at night, trying to understand how meaning might be embedded in structure rather than broadcast as signals. Materials scientists, once preoccupied with ice sublimation and rock fracturing, began sketching ideas for non-biological information carriers that could survive cosmic timescales. The object turned their specialties inside out, forcing them to think like detectives examining a crime scene when the victim and culprit were both millions of years gone. One of the most intense efforts focused on building laboratory analogs of what the Webb instruments had implied. Teams tried to reproduce similar patterns with layered alloys, exotic ceramics, and complex composites under extreme conditions. High-temperature furnaces, vacuum chambers, and radiation sources all came into play as they attempted to coax ordinary matter into behaving as strangely as the observations suggested. Again and again, the results fell short. Certain combinations mimicked parts of the spectral profile, but never the whole. Others matched portions of the thermal behavior, but lost the structural hints. The failure was not embarrassing so much as humbling. It implied that whatever processes had shaped 3I Atlas involved thermodynamic paths or manufacturing regimes that human technology could barely imagine. The more those experiments faltered, the more theorists stepped into the spotlight. They began sketching frameworks for what some called information-bearing matter. Instead of thinking about structure as incidental to function, they treated the material fabric of an object as the message itself. In those discussions, 3I Atlas was not just an artifact, it was a text written in grain boundaries, dopant patterns, and lattice deformations, just as DNA encodes life's instructions using nucleotides. Perhaps an advanced civilization had used metallic and mineral matrices to encode something meant to survive when their biology, language, and even star of origin were long gone. This line of thinking led to intense cross-disciplinary workshops. Astrophysicists found themselves sitting beside linguists, archaeologists, cryptographers, and philosophers, all looking at the same data and seeing different shadows of possibility. Linguists wondered about redundancy, error correction, and whether any recurring symmetry might hint at an underlying grammar embedded in the structure. Archaeologists, used to reconstructing lost cultures from pottery shards and ruins, urged caution against projecting present-day assumptions onto an unknown past. Cryptographers talked about compression and how one might hide staggering volumes of data in patterns that looked, to naive observers, like meaningless noise. Anthropologists and sociologists added another dimension. They asked what it meant for a species to invest such effort into building something that might never be seen. Was 3I Atlas a monument meant to testify to a civilization's existence? A tool in an ongoing project whose context humanity could not perceive, or a desperate attempt to speak across time, launched when its makers already suspected that their era was ending? Each interpretation carried implications about the psychology and values of those unknown beings. The object became a mirror, forcing humans to ask what they themselves might choose to preserve if they faced similar odds. Inside space agencies, the discovery sparked quiet policy debates that would never appear in public press releases. Up to that point, guidelines for dealing with unfamiliar objects in the solar system had focused on planetary defense, contamination, and scientific priorities. Suddenly, there was a new category to consider: potential artifacts of extraterrestrial technology. Some argued for strict protocols of non-interference. Until humanity knew more, they insisted, the appropriate stance was passive observation only, avoiding any action that might alter the object, disturb its trajectory, or introduce artificial signals that could complicate interpretations. Others took a different view. If 3I Atlas truly was a construct, they said, then it might be designed to respond to certain stimuli. Failing to engage with it through targeted pulses, illumination patterns, or other carefully controlled probes could mean missing the only chance to trigger dormant systems. A heated argument emerged between those who saw any intervention as sacrilege against a relic and those who believed that respectful interaction was not only justified but necessary. For the moment, the limitations of technology settled the matter. Humanity lacked the means to mount a direct mission, and any remote engagement would be constrained by distance and power. Still, the ethical questions lingered. Beyond policy circles, philosophers and ethicists began using the discovery as a touchstone for rethinking old questions about contact and responsibility. They wrestled with scenarios in which humanity might one day leave behind its own interstellar debris. If another species eventually encountered those remnants, what impression would they form of their long-vanished makers? Would they see wisdom, care, and curiosity, or chaos and carelessness? Thoughts about 3I Atlas thus bent back toward Earth, inspiring new conversations about how humanity wanted to be remembered, whether by others or by distant descendants trying to reconstruct their own past. Scientists working on models of long-term habitability and existential risk felt the implications keenly. Here was an object that potentially demonstrated that technological sophistication did not guarantee permanence. If it represented a culture that had already vanished, then intelligence was no safeguard against cosmic or self-inflicted catastrophe. Some researchers began integrating this possibility into their models of the so-called Great Filter. that hypothetical set of obstacles that might explain why the observable galaxy seems so quiet. Perhaps advanced societies were not rare but brief, leaving behind only hardened traces in the interstellar medium. In this context, 3I Atlas became a cornerstone of a newly invigorated field, sometimes described as cosmic archaeology. Rather than seeking live broadcasts or active beacons, it focused on scattered remnants, anomalous objects, long-lived structures, and chemical signatures that natural processes struggled to explain. The Webb data provided a concrete case study, encouraging researchers to think beyond traditional radio searches and look for evidence of engineering embedded in planetary rings, stellar atmospheres, or the distribution of dust grains. Every oddity became, at least for a moment, a candidate clue. This shift in perspective began to reshape planning for future instruments. Proposals for next-generation observatories no longer spoke only of hunting exoplanets and mapping early galaxies. They also mentioned scanning for technosignatures writ into matter itself. High-resolution infrared and sub-millimeter designs were re-examined to see how well they could discriminate between natural crystalline arrangements and those that might suggest deliberate fabrication. Ideas for interferometric networks, arrays of telescopes acting in concert to achieve extreme angular resolution, gained urgency. The logic was simple. If relics like 3I Atlas existed, they might not be unique, and better eyes might find siblings marooned around other stars. At the same time, engineers and mission planners could not help imagining what it would take to intercept such an object directly. Studies that once seemed like pure speculation, interstellar flyby probes, advanced propulsion concepts, high-velocity interceptors, were pulled out of old folders and given new life. The goal was not necessarily to reach this particular visitor, whose path and speed made it a moving target, but to be ready next time. Every newly detected interstellar object, natural or not, would now be viewed as a potential candidate for close examination. That anticipation shaped conversation around nuclear thermal engines, laser-driven sails, gravitational slingshots, and other means of closing vast distances faster than conventional chemical rockets would allow. Beyond the technical and theoretical realms, the discovery seeped into culture in less formal ways. Writers began crafting stories centered on ancient probes drifting between stars, each carrying fragments of memory from lost civilizations. Artists rendered their visions of the interior of 3I Atlas as vast hollow vaults lined with unreadable glyphs or as densely packed honeycombs of unknown devices. Composers wrote music attempting to capture the eerie balance between silence and presence that defined the object's existence. It was as if the entire species, lacking any real way to touch the object, sought to reach it through imagination, weaving it into shared myths. Teachers reported a surge of interest among students in astronomy, physics, and engineering. Children who saw rendered images of the object's elongated form and read about the mysteries in its data began asking questions that skipped past the boundaries of school curricula. They wanted to know not just how stars formed, but how long a civilization could live, what it meant to send something into the dark, knowing you might never see it again, and whether humanity might someday build its own messengers to wander the void. Even as the discovery inspired creative and aspirational responses, it also stirred deeper anxieties. For some, the idea that the universe might be filled with abandoned artifacts instead of living voices suggested a kind of cosmic graveyard. Earth's night sky, once a symbol of possibility, began to feel heavy with the weight of unspoken stories. Psychological studies started examining how exposure to the concept of ancient interstellar relics affected people's sense of security, purpose, and future orientation. Interestingly, responses tended to fall into two extremes: either heightened motivation to push human progress forward, or a quiet, numbing fatalism. Within the communities directly handling the data, however, the dominant emotion remained a kind of rigorous wonder. They knew they were staring at something that might define an entire scientific era, but they also understood the dangers of wishful thinking. Teams instituted strict internal checks to guard against confirmation bias. Analysis groups were kept partly independent, comparing results without sharing interpretations at first to see whether different methods converged on the same anomalies. Whenever a pattern emerged that seemed too suggestive, someone would ask whether an overlooked mundane explanation might still exist. It was an exercise in balancing imagination with restraint. A key puzzle that consumed many late-night discussions revolved around the interior of the object. External observations provided tantalizing but incomplete hints of internal heterogeneity. Working from those clues, structural modelers proposed various configurations. One scenario envisioned a central core shielded by multi-layered shells, each designed to absorb, reflect, or re-radiate energy in precisely tuned ways. The outer layers in this model acted as sacrificial armor against micrometeorite impacts and radiation, slowly degrading over time while protecting a more delicate interior. Another configuration imagined distributed compartments, each storing separate functional units, so that the loss of one would not doom the whole. There were also more radical ideas. Some theorists suggested that rather than containing recognizable machinery, the interior might be filled with a metamaterial whose very bulk encoded information. The orientation of grains, the distribution of impurities, and the microscopic voids could act as a three-dimensional storage medium, akin to a hologram where every part contains the whole. In that case, fragmenting the object would not necessarily erase the message. Any sufficiently large piece might contain copies of the original data. Such robustness would fit the apparent theme of endurance that pervaded the analysis. Contemplating those possibilities, a few researchers began thinking about what tools would be needed to read such a message, if it existed. They imagined instruments capable of mapping internal structures at nanometer resolution from a distance, perhaps by using interferometric observations of scattered radiation or exploiting subtle polarizations in reflected light. Others speculated about future missions that might capture a passing interstellar object, or at least deploy swarms of tiny probes around it, sampling its environment and building composite pictures of its external and internal makeup. Every such concept faced enormous practical challenges, but the sheer existence of 3I Atlas gave them a sense of urgency that abstract discussions had never achieved. The discovery also rekindled attention to earlier interstellar visitors. Archival data from past observations were reprocessed with fresh eyes and improved algorithms, searching for faint anomalies that might have been missed. While none matched the peculiar richness of the new object, the exercise revealed that the galaxy's wanderers were more diverse than previously thought. Not every irregularity implied engineering, of course, but the exercise underscored a key lesson. The solar system was not a closed, static place, but a crossroads occasionally visited by messengers from further afield. For those studying the philosophical side of the event, a particularly thorny issue lay in how to describe the object without overstating what was actually known. Language quickly became a battlefield of nuance. Calling it a probe implied purpose. Calling it debris implied accident. Calling it a relic implied finality. Some opted for neutral terms like interstellar body with anomalous properties, even though such phrases stripped away the awe. Others believed that naming the possibility of artifice openly was essential to honest discourse. To tiptoe around it would be to smuggle assumptions into scientific conversation without admitting them. The tension between cautious description and evocative imagery filtered into public communication as well. Outreach materials tried to walk the line between sparking curiosity and avoiding sensationalism. Illustrations were labeled explicitly as artistic impressions, not literal images. Explanations emphasized that there could be exotic but natural explanations for some aspects of the data, even as they acknowledged that current theories struggled to provide them. In many ways, the process of explaining the mystery to the public became an exercise in teaching how science grapples with the unknown. In more private settings, some scientists allowed themselves to speak more freely. Over coffee or in late-night conference calls, they speculated about what kind of society would build such a thing, and what circumstances might compel them to send it. They asked whether it was an instrument of exploration, a vessel carrying stored consciousness, a seed of self-replicating machines, or something that did not fit any human category. None of those ideas made it into official reports, but they flickered in the spaces between spreadsheets and simulation outputs. Meanwhile, thinkers concerned with long-term trajectories of human civilization began using the discovery as a starting point for new roadmaps. If the galaxy might contain scattered remnants of other technological lineages, then humanity's own future projects could be conceived in similar terms. Plans for starshot concepts, world ships, and long-lived beacons were revisited with an eye toward extreme durations. Materials research pivoted more sharply toward structures capable of retaining integrity over millions of years, not just decades or centuries. Redundancy, self-repair, and graceful degradation became key themes in proposed designs. In this sense, 3i Atlas acted both as a challenge and as a tutor. It posed questions about endurance, resilience, and meaning that cut across fields, but it also offered hints through its own persistence. If its builders could construct something that survived unthinkable distances and times, then perhaps similar feats were within reach of human ingenuity as well. The object, though remote and inaccessible, became an aspirational benchmark. Some of the most profound reflections arose from considering the quietness that surrounded the object. It did not broadcast, maneuver dramatically, or display any behavior that decisively signaled the presence of consciousness. It simply followed its path, governed by momentum and subtle anomalies, bearing whatever history lay locked within it. That stillness forced a reconsideration of what kind of evidence people had expected from the search for other minds. Many had unconsciously anticipated something theatrical, a clear signal, a beacon, a deliberate greeting. Instead, they confronted something indifferent to their arrival on the cosmic stage. This dissonance led to a broader meditation on humility. The universe, it seemed, offered no guarantee of encounters that centered human perspectives or timetables. If 3i Atlas was indeed a testimony to another intelligence, then that testimony had not been crafted with humans specifically in mind. Humanity might not be the intended audience at all, merely one of many possible readers along an unimaginably long trajectory. Coming to terms with that decentering proved difficult but necessary. The event also catalyzed new lines of thought within theology and spirituality. Different traditions interpreted the object through their own lenses, seeing it as evidence of a cosmos saturated with creativity or as a sobering sign of the transience of all created things. Some found comfort in the idea that life and mind had flourished elsewhere, even if only their works remained. Others saw in the object a reminder that material achievement, no matter how grand, could not ensure perpetual survival. Debates emerged about whether finding traces of other beings elevated or diminished human significance. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on James Webb 3i Atlas data revelations? We want to hear from you. Thank you for watching and see you next time.